All right, so we're going to look at an activity where we're going to consolidate our understanding of with and without replacement. So for context here, I've got a container with some black and blue pens, and we're going to do a series of calculations, basically determining the probability of us selecting black pens or blue pens, depending or independent of us having selected a pen the first time. So the first question has asked us to set up a tree diagram that's representing the information. So the information tells us that we have 4 black pens and 7 blue pens. So it's just important here to make sure that you understand or realize that in total, or calculate, our total number of pens is 11. Now this is going to be important because in the first question where I've asked you to set up a tree diagram, I've also said to write the probabilities on each of the branches. Now we're only going to set up the first event, given that I've given you no other information. So we've got our black pens and we have our blue pens. Now we have 4 black pens, so out of 11, so I'm going to write my probability as a fraction, so I've got 4 out of 11. Then we have 7 blue pens, so I'm going to write 7 out of our 11 pens are blue. Now that's it. So then the second question says to calculate the probability of her, being me, selecting a black pen the first time, putting the pen back in the container and then selecting a blue pen. Now the reason I've highlighted or underlined putting the pen back is because when we look at these kind of events, these 2-step events, we need to figure out has replacement happened or not. Now by me putting the pen back in my container, it means that replacement has happened. So I'm going to write replacement has happened. And what this means for us is that the total number of pens that we can choose from has not changed. So I'm just going to write that down really quick. So now let's have a go at drawing out a tree diagram for us to then calculate the probability of my little event happening. So my first 2 branches are going to be the initial selection. So that'll be black pens here and blue pens. Now we know that my probability of selecting a black pen initially is 4 out of 11, and then selecting a blue pen is 7 out of 11. So I selected a black pen the first time and then I selected a blue pen. So we're going to draw another 2 branches off the black pen because that's what I selected the first time, or the color black. And then my next 2 branches will still say black and blue. So this represents the black pens I can choose from, and this here represents the blue pens I can choose from. So now writing my probabilities here, I can once more select 4 black pens out of a total of 11 because I replaced the pens in the container from having selected them the first time. So in the second time, I have 7 out of 11 blue pens to choose from. So now I'm going to write the probability of me selecting a black pen and then a blue pen the second time is going to be equal to 4 out of 11 times 7 out of 11. So that's going to be 28 divided by 121, or you can put that into your calculator and get a percentage as well. That's about 23.14%. Now, I would say to reduce our rounding errors, just leave your answer as a fraction and simplify where you can because it is going to eliminate any rounding issues you get. All right, so the next question says, after selecting a blue pen the first time, I then keep it aside and select a black pen. So we're asked to calculate the probability of this happening, but let's go back and actually look at the information. So I selected a blue pen the first time, I then kept it aside and then selected a black pen. So in the question above, I said, have a think about whether replacement has happened or not. The fact that I keep it aside means no replacement has happened. And this now means that the total number of pens we can choose from has also decreased. So now we need to be very careful when we're constructing our tree diagram. So again, let's start with our first event. So my two branches are going to be black and then blue. So my probabilities will be 4 out of the 11 and then 7 out of 11. And then I'm going to do another two branches. This time I selected a blue pen first and then I selected a black pen. So drawing my branches off the blue pen or blue pens. So I've got black and then blue. Now, because no replacement has happened, this means that our total number of pens to choose from has decreased. So the first time I selected a blue pen and then I kept it aside and I didn't put it back in the container. This now means I only have 10 pens to choose from as a total. Now, because I picked a blue pen the first time, I still have 4 black pens to choose from. And since I picked a blue pen the first time, the number of blue pens I can choose from has also decreased. So I'll just quickly write that as a note on the side. So now, in order for us to calculate the probability of this event happening, so let's write the probability of selecting a blue pen first and then selecting a black pen is going to be 7 out of 11 times 4 out of 10. So now that's going to be 28 on 110. Simplifying that now, so we get 14 divided by 55. And again, we can work out the percentage for this as well. So that'd be about 25.545. Yeah, let's say about 25.45%. So now on to the last question. This one's a little bit trickier, so do take the time to deconstruct what the question is asking. So I selected a blue pen the first time. I kept it aside and then selected a black pen the second time. I then returned the black pen and selected a blue pen on my third turn. So when you think about what this question is saying, there are 3 events that have happened. The first event, I picked a blue pen. The second event, I picked a black pen. And then the third event, I picked a blue pen again. So let's have a go at setting up our tree diagram and then we'll go back and write our probabilities in. So my initial one will be black pen and blue pens. Now I picked a blue one the first time, so then branching off the blue pens, we've got black and then blue pens to choose from. So I'm going to say this is our first event, second, and then after picking a black pen the second time, I'm then going to have another 2 branches coming off that because my third time I picked a blue pen. So now let's start with our probability. So initially we started with 4 black pens out of a total of 11, and then I had 7 blue pens out of a total of 11. Now, from the first event to the second event, I kept it aside. I picked a pen and then I put it aside, which means no replacement. Now we know when no replacement has happened, our total number of pens to choose from decreases. So now I have 4 out of black pens to choose from, or I have 6 out of 10 blue pens to choose from. Again, the reason being that the first time I selected a blue pen, which means my total number of blue pens to choose from out of my container will now decrease. So the second time I selected a black pen, I then returned it and selected a blue pen. So between the second and third event, we know that replacement has happened. So I've taken a pen from the second time, put it back, and then made a third selection. So this time my probabilities will still be out of 10. However, the numbers won't change. So for example, out of 10 pens in total, I still have 4 to choose from for black. Or out of 10 total pens, I have 6 blue pens I can choose. So now I need to calculate the probability of this happening. So the probability of selecting a blue pen, then a black one, and then a blue one again. So following this pathway, so I'm just going to highlight it in a different color. So we've got basically this, then that, and then that again. So that's going to be 7 out of 11 times by 4 out of 10 times by 6 out of 10. So now multiplying my probabilities together, I'm going to get 42 divided by 275. Now as a percentage, that's going to be approximately 15.3%. Actually, we'll say 15.27%. And that's it for calculating with and without replacement for a little activity about the pens in my pencil case.